Hello, everybody. Welcome to YouTube University. Um, Today's lecture is pre-algebra. I'm going to talk about um, what we can do, how to do the basic math, basically. So when it comes to numbers, we have operations. So we have addition, which is just adding two things together. 2 plus 2, or 3 things. I meant to do only 2, but we can do addition like that, or we can do subtraction, which is just negative addition. So 2 plus, negative 2 equals 0. Or, if we could also write it as 2 minus 2 equals 0. Now, if we're subtracting a negative number, it becomes a positive number, surprisingly enough. So that's addition and subtraction. We can also multiply, which is like an x or a dot. And I'm sure there's other symbols, but we have 3 times 3, and it's just basically repeated addition. 3 plus 3 plus 3 is what 3 times 3 is, and it's equal to 9. Division is a little spicier. It is written like that, or with a bar, and it's a fraction. Now when we do these, we can, we obviously know that this is equal to 3. 9 is also 3 times 3, and we're dividing by 3. We can just cancel one of those terms out, and we just have 3. And we could still write it as a fraction, 3 over 1, but that really doesn't serve much of a use. But we can think of it like cutting up a pizza and, sharing it. Or, even more. 1, 2, 3, 4, 5. Imagine if I could actually draw and make those a little more even. That would be nice. Then there's also exponentiation, which is repeated multiplication. So 5 to the third is 5 times 5 times 5, which is just 125. I'm not going to write out all the repeated additions. Exponents can also be negative, which when you learn about this, it just means that you write it like that, and it's like that. You just flip it. So if you have 1 over 5 to the negative 3, now it's just 5 to the third, which is 125, and I don't know why I'm writing like that. Maybe I'm nervous. I don't know. So there's more operations, but I'm not going to cover them right now. These are the basic 4 numbers that I'm going to cover right now. And operations have a specific order. So one thing you might have learned before is please excuse my dear Aunt Sally, which is an acronym for all of it. So we have the parentheses. Anything inside this parentheses has to be resolved first, and then exponents. So whatever power it's being raised to, and then the multiplication, division is done next, and it's done left to right, and then finally the addition and subtraction. So it's pretty simple when you look at it, but it can get a little tricky. On the board, I wrote this problem: 3 plus 5 times 2 minus 8 divided by 4. So because we have different operations going on right here, we have to follow the order. So the first thing to do is the 5 times 2, so 3 plus 10 minus 8 divided by 4. Well, I guess we could also do the 8 divided by 4 in the same step, but for now, it's probably best to not skip steps or combine steps. So now it's 3 plus 10 minus 2, 13 minus 2, or 11. Now for this problem, we have to resolve what's inside this parentheses first. So 6 minus 2 is 4, divided by 2 plus 7 times 3. So we want to go left to right, like that way. So 4 divided by 2, 2 plus 7 times 3, and that's just 2 plus 7, 21. Sorry, forgot to do it, and then 23. Now I have written a problem that includes an exponent. So 3 squared is just 9 right here. This is just 3 times 3. As I said, it's just repeated multiplication. If it was 3 cubed, it would be 3 times 3 times 3, but we just have 3 squared, so 2 plus 9 minus 4 times 5. 2 plus 9 minus 20. So it's just negative 9. Now we have brackets and exponents and everything here so far. So first is the parentheses or the bracket, and then now we do the exponent, and then the division, that's not legible, 47. So there's this viral problem that has confused a lot of people. So it's just like any other problem though, so just you just have to follow the order of operations. First is the parentheses, and then the division, which leaves us with 9. Similarly, with this other viral-ish problem, we have to first do what's in the parentheses, the operation inside there, the 2 plus 2, which is 4. And then we do the division, 4 times 4. Now it's 4 times 4. When we have something like that, that's just like a implied like multiplication. It gives us 16. Now I want to kind of switch gears a little bit and talk about fractions for a little bit. So sometimes the goal of a fraction is to just reduce it. So we could write this as like 4 times 2, or just 2 times 2 times 2 over 5 times 2, and it's just 4 over 5. Now, sometimes that's good enough. Sometimes we want to convert it into a decimal. To do a decimal, we just, okay, well, we have 5, and we perform a division. There's no even amounts of times that 5 goes into 4, so now we can go into how many times it goes into, like, let's say 40. Now it's 8, and we just add the decimal point to show that it's not a whole number of times that it goes into 4. And you know, we can still do addition, subtraction, multiplication, but it's a little different. With addition, we want to have the same denominator. So we have the top, which is the numerator, and the bottom is like the denominator. Well, not like, it is. When it's easy like this, when they both have the same denominator, we can just add them up and it's just easy. And in this case, 5 over 5 is 1. Now if the denominators are different, let's say we have 1/3 plus 1/5, what's that equal to? Some people might think it's equal to 1/8, and that is totally wrong. You have to convert them to be the same denominator. So what you do is you multiply by 1, and when you do that, you get a common denominator. If, say, for example, there are several fractions, it's supposed to be a 4, we could do it, step by step, where we're multiplying by 1 the entire way through. And we could do it like that. Personally, I kind of like that method. I like to give myself a little more work. But we can also just multiply the 3 times the 4 times the 5 all together and get to 60. And when we're looking at how do we add it then, well, for when we have the 1/3, we have 4 times 5, that's 20. Just write like a little 1/3 right there, a little arrow maybe. For the 1/4, it's 3 times 5, which is 15. And then the 1/5 would get 3 times 4, which is 12. And then we get 12 over 60 plus 15 over 60 plus 12 over 60. Oops, that is not a 60. And that's 47 over 60. And that's much faster than adding or going through it step by step, but they both work. They both would give the same answer because it's doing the same thing, just in less operations. Now, to multiply and divide fractions, it's basically just like multiplying numbers. Ooh, I don't like that. If we have numbers, let's say we have like 2 over 3. Okay, I had the wrong tool selected, but it's just like multiplying numbers. And you want to look for like cancellation. See, these all cancel out and just becomes 1. But other fractions, let's say we have 2 over 3 times 4 over 7. That's just 8 over 21, because this multiplies that, this multiplies that, and we get the 8 over 21 that way. Dividing fractions is a little different. 2 over 3, let's say we're dividing by 3 over 2. Do you think it cancels out? No, it doesn't. So in this instance, the division turns this second fraction into like a multiplication. You're multiplying by the reciprocal. So 2 over 3 times 2 over 3, which becomes 4 over 9. The reciprocal is just the opposite of it, so it just becomes 2 over 3. It just switches the numerator and the denominator. Okay, so let's try this problem out. So first we want to multiply whatever's in like the parentheses and the brackets. So and you go left to right. So I'm going to do this one over here first. So 3 over 5 times 7 over 9. So 21 over 45. And then dividing by this fraction. But this fraction is going to be, let's see, 2 over 3. We're dividing by 5 over 6. So we can just multiply by 6 over 5. Now, just rewriting again. Two times 6 is 12 over 15. Now, where you can remove the parentheses and flip the fraction around, and this comes out to we can write this by the prime factors. 7 times 3 over 9 times 5 times 5 times 3 over 4 times 3. And 3 times 3 right here is 9. The 5. And that gives us 7 over 12 as our answer. That pretty much sums everything up so far. This is just a beginning video for me, so expect it to get much harder pretty quickly. The next topic will be just some basic algebra, and we'll work our way up to calculus and above.